The Linux kernel is considered the heart or brain of the Linux operating system. Now, technically, it's considered the low-level core. And what that means to us, if you can imagine a car, you have air conditioning, you have automatic windows, maybe a sunroof, things of that nature. All of those are what we consider creature features, or additional components of functionality of the vehicle. Well, none of that would operate properly if you didn't have the motor. So the motor would be the core of the vehicle and allows all additional pieces of the vehicle to operate properly. And the Linux kernel does the same thing for each variation of the Linux operating systems. In addition, it provides the abstraction layer for applications, software, and peripherals to communicate with other hardware and software components. So it's almost the glue that holds the software to the hardware. It also controls access to the various mission-critical components as far as hardware is concerned. So what that means to us is if an application wants to access physical RAM inside of a system, it has to go through the kernel to do so. If an application wants to request processor time, it's got to go through the kernel. So as you can see, the kernel is definitely an important part of the Linux operating system. It's going to be required to be working properly in order for anything else to function, especially applications. Now, when we describe the kernel as being modular, that means that you can choose what components to build with the Linux kernel. That's definitely a huge difference between Linux and Microsoft Windows. Microsoft Windows allows you to install their operating system, and you get what you get. You really don't have a whole lot of say in what components of the operating system are loaded. For example, Internet Explorer is so deeply integrated into the Microsoft Windows operating system that it can never be fully removed without destroying the Microsoft kernel. Well, the Linux kernel doesn't have that level of restriction. It's almost like a puzzle. You get to choose what pieces that you put into the puzzle. So by loading the kernel in a modular state, it's actually called compiling. And the beautiful thing is when you install Linux, you compile your kernel using the settings that you choose. But at any time, as desired, you can recompile the kernel to suit your current needs. So it's definitely a huge feature and definitely a point for the Linux operating system. Now, the Linux kernel is much like the Microsoft Windows platform in how Microsoft continues to develop their operating systems and continues to make modifications and put out patches and things of that nature. The Linux kernel is no different. So the Linux kernel is definitely going to be closely monitored for security problems, for new component support such as USB and hot swappable drives, things of that nature will always be features that are adapted to with the Linux kernel. Now, the kernel version is actually a 3-digit decimal number. And this basically allows us to identify exactly what version of the core Linux operating system that we're running. And basically, it breaks down like this. Our major kernel number is going to be the first number, separated by a decimal for the minor revision number. Now, your minor number is going to be either even or odd. If it's even, then it's definitely considered a stable version, meaning that it's ready for production. If it's an odd number, such as 2.5, then that lets us know that it's actually an in development state of that minor kernel revision. So for business applications and production environments, we're going to want to rely on that even minor revision number. And finally, the patch level. And this basically lets you know where you stand on being up to date for security and functionality patches.